Moving on to 7.5, our friend rationalizing denominators. Our first lesson with this. Rationalizing denominators essentially means you're going to be working with an expression that has a radical in the denominator, and we don't want a radical in our denominators. I want to know if I'm working with thirds, if I'm working with fourths, or if I'm working with fifths or halves, what I'm working with. I don't want to have an expression like this. That's the square root of 2. I don't know exactly what that is. I do know what thirds are. I do know what fourths are. I do know what fifths are. So we are going to then be working to change the fractions like this, 7 times over the square root of 2, into something to have a rational denominator. So I know what size of fraction I'm working with. So here's how we do this. I have 7 over the square root of 2, and I want this denominator, the square root of 2, I'm going to change that. So let me show you how that's done. The first thing I'm going to do is I need to then think about how can I change, what can I multiply by to get rid of this radical on the bottom. I know from past experience that if I do the square root of 2 times the square root of 2, I get 2 as an answer. So in order to rationalize the denominator, I'm going to multiply both the numerator and denominator by the square root of 2 over the square root of 2. What does that do for me? Then I have my numerator, so I do top to top, I multiply, and I have 7 times the square root of 2 over square root of 2 times square root of 2 is 2. Now I know I am dealing with halves. So that I have numerator of 7 times the square root of 2 over 2. So now that denominator is rationalized. I know I'm dealing with halves. I'm not dealing with the square root of 2's, whatever that turns out to be. That's an irrational number. I want the bottom to be rational. I know what 2 is. I know what half of something is. That I can work with much easier. So this is what we mean by rationalizing a denominator. We're going to change it from an irrational number to a rational number, one that I can make more sense of. So let's look at a couple more examples. And these are today, this time from this assignment, are going to be all square roots in the bottom. On this one, I have 2 times the square root of 9 all over the square root of 16 times y. Okay, so let's take a look. First of all, do you recognize this? 16 is a perfect square, isn't it? So before I even do any rationalizing, if there's a perfect squares that I can deal with, I'm going to do that. So I'm going to actually have a perfect square on both my numerator and denominator, so I'm going to work with those. So I'm going to then write, whoops, I want a different color. I'm going to then do this. I'm going to say that I have 2, and I know that the square root of 9 is 3, so then that changes my numerator to 6. And in my denominator, the square root of 16 happens to be 4, so I have a 4, it's a rational number, times the square root of y. So what will I do now? Well, notice I have a 6 and a 4 here. Let's simplify those, make it easier for us. And both of those are divisible by 2, so then I have 3 over 2 times the square root of y. I divided both of those by 2, 6 and 4, but I divided both by 2, so I have 3, and 4 divided by 2 is 2, times the square root of y. Now I want to get rid of this irrational number on the bottom. What am I going to do? I am going to multiply. I'm going to multiply by the square root of y. So I'm just going to take the irrational number I have on the bottom, and I multiply both top, numerator, and denominator by that irrational number. What do I end up with? I end up with 3 times the square root of y as my numerator. And in my denominator, I have 2 times the square root of y times the square root of y. So I end up with just plain old-fashioned 2y. Now my bottom is a rational number. I have the irrational number in the numerator. And I don't need to go any further than this, because what I'm asked to do is only get the denominator into a rational number. Simplify everything you can, as I did to start with here, and then I rationalized it. One more example for you. And this one again has our quotient rule in it. So here, looking underneath, I have the square root of 5m over 11m. Well, how am I going to deal with that? Well, I'm going to use the quotient rule. And I'm going to do this. I'm going to say, okay, I am going to break this up into the square root of 5m over the square root of 11m. And now I will multiply both numerator and denominator by the irrational number in the denominator, which is 11n, the square root of 11n. So I do it with both of them. And what does this equal? Oops, didn't mean to draw a lightning bolt there. Okay, so I have 11, square root of 11, or I'm sorry, square root of 5m times the square root of 11m gives me the square root of 55 times m times n, and all of that should be under my square root symbol, all over, and then the square root of 11n times the square root of 11n is 11n. And at that point, I'm done. And I have a rational number on the bottom. Now your rational's been moved out of there. It's up to the top. And this is what I want you to, this is how we're going to start dealing with rationalizing denominators. We have just a plain, simple fraction. This is our method of doing it. What I want you to do will be this. Let me type that there for you, out here for you. That starts on page 448. And here's the numbers I want you to do. 448, Mr. Ellenberg, not 444, 448. All right, the numbers I want you to do are 1, 3, 5, 9, 13, 17, 19, 23, and last but not least, 25. Okay, be sure again to check answers. Boy, it would help if I could type something. Check answers, but then, and keep this. I want you to keep this until you finish lesson 2. So check your answers with this, but keep it until you finish lesson 2. Time to stop the video and time to get to work. Let me know how I can help you.